So we have three factors. And let's take them one at a time. So the easy one is the sign. It's just x over 5. And I don't need the dot here because I'm just dividing by a scalar. And for that, you don't need the dot. But I could put the dot in and it wouldn't hurt anything. Right? Then I'm taking e to the x squared, or minus x squared rather. Oops, come on. Minus x, but x is a vector. So I need the dot there. And then I'm multiplying all these together, right? So I'm multiplying 5 times this. Well, 5 is just a scalar, so I don't need the dot. But now I'm multiplying this, which is a vector, times this, which is a vector. For that, I do need the dot. All right. And just, we haven't covered plotting yet, but I'm sure you remember something about it from 1181. So let's just do a quick plot to see what it looks like. All right, and that's what that function looks like. All right. But if you have any trouble remembering when do I need the dot and when don't I, well, just put it in everywhere because it's not going to hurt anything. I can put them in there and I'll get exactly the same thing. Okay. Any question about that? All right. So that's applying the standard mathematical functions to arrays. But there are other functions that are specifically designed for arrays. It wouldn't make any sense to apply them to a scalar, like statistics, mean, median, standard deviation, or max and min. Give me the maximum value, the minimum value. All right. So, and these do pretty much what you'd expect. Mean gives you the average. And I always get tripped up when I go back and forth between MATLAB and Excel. In Excel, it's average. In MATLAB, it's mean. Right, so you have an array of numbers here. Just give me the mean of those numbers. Here we have an array, a vector. Give me the largest number, the maximum value in that array. Or give me the smallest number, the minimum value. I shouldn't say the smallest because some of them can be negative. So, but just the minimum value. All right. Now notice I did something a little different here because you have to do this in the exercise. If you put a second output argument here, then the max function or the min function will give you not only the value, but also the index where it occurred. In other words, the position in the array where it occurred. So this is saying the maximum value in this array was 10, and it was the 5th number in the array. As you can see, right? It's the last one, which is the 5th number. Okay, so that's a handy thing. Sometimes it's nice to know not only what was the maximum value, but where in the array did that maximum occur. All right, so that's one way of using the min and max functions. There are other ways, and people sometimes have a hard time keeping them straight because we're going to have you use the min and max functions several times throughout the course using it different ways. All right, so the first way is just give me the minimum or maximum value in a single array. Another way is you give it 2 arrays and it compares them element by element. And for each corresponding pair of elements, gives you which one is less. Right, so it gives you, oops, wrong section. So it gives you an array of results. Right, so it looks at that and says, which is less, the 0 or the minus 10? The answer is the minus 10. Then which is less, the 2 or the minus 5? It's minus 5, and so forth. Okay. Or the second argument can be a scalar, which means give me each element of this array or that number, whichever is less. Okay, so the first one's going to give me either the element of the array or 5, whichever is less. And then the same with max. So that gives me each element of the array or 5, whichever is greater. All right. So if you learn to use this kind of technique, it makes your code much more efficient Because if you think back to 1181, you could have done this as well with a loop and an if statement. Loop over the array. If it's less than 5, then return the value, that value from the array, else return 5, right? You could do all of that in one line with the min or max function. Now, you might be wondering, if you're thinking ahead, what would happen if I applied one of these statistical functions like min or max or sum or mean to a matrix? Well, it does not, as you might think, apply to the whole matrix. And so let's say I do the sum function. It does not give me the sum of the whole matrix unless I tell it to. And so by default, if I just do sum of m, it gives me the sum of each column. Okay, so by default, these statistical functions, when you apply them to a matrix, they operate column by column. You get a vector of results. If that's not what you wanted to do, if all you really wanted was the sum of all the numbers in the matrix, you put all. Okay, sum m comma all means give me the sum of the whole matrix. Now that's a relatively recent feature. So if you have a really old version of MATLAB, it's more than say 2 years old, that might not work. So in that case, you can just do a double sum. Take the sum of the sum. It'll do the same thing. Okay. Now that, as I said, if you just do sum of m, it gives you the sum of each column. Well, what if you wanted the sum of each row? Well, there are 2 ways you can do that. You could take the transpose of the matrix and then take the sum. Or you can put a 2 here, which means sum by rows instead of by columns. All right, so put it, sum of m comma 2 means sum the matrix M row by row instead of column by column. And you can do the same thing with the max and min functions, except, unfortunately, with max and min, they already used this second argument for something else. It's like this: if you want to compare 2 things and take the larger of the 2, larger or smaller of the 2, that's what the second argument is for. So if you want to sum, or sorry, not sum, take the max or min of each row, you put an empty second argument, and then you put the 2. All right, so it's just a tricky syntax you have to remember. To remember all these things, or if you have trouble remembering all these things, I remember them because I've been doing them for years, but you can always go back to the documentation. I do doc max, opens up the documentation page and shows me all the ways. So first, there's a summary of all the different ways you can use that function. And then there's a detailed explanation for each of those. All right. So this one, for example, is if I want to get not only the max value, but also the index where it occurred. This one is if I want to specify to sum by, or sorry, not sum, take the max of each each row instead of each column, and so forth. And there's some other things here that we won't even cover in the class, like something to do with treating what are called nans, which are invalid numbers. All right. So don't forget, the documentation is your friend. All right, any questions so far?